Hi, I'm Alex Murray from Group 12 in the Water Filtration Project, and our group's primary design goal was to cut costs in all other areas of the filter in order to maximize the amount of medium we could purchase. So we designed to deviate from the standard housing, and instead we built a styrofoam cup system, and as you can see, we were able to fill this top cup nearly to the top with charcoal, and in turn that effectively filtered the water.
Here we have a breakdown of the costs for our filtering apparatus. Our total cost was $189. We used charcoal, styrofoam cups, cardboard, duct tape, a fine coffee filter, cotton balls, and a paper cup. We also included the tools cost. Our most significant cost, as you can see, came from the charcoal. We spent $105. Had we decided to also include a housing, we would have surely gone over our $200 limit.
Here's a demonstration of how our filter separates the dye from the water. After about a minute, all the dyed water has run through the filter and has collected in the reservoir. As you can see, some carbon particles remain, but I believe that that's due to wear and tear in the inner coffee cup strainer.
Here we have a cross-sectional diagram of our water filter. In the top half of our water filter, we had a mix of activated charcoal and cotton balls, which was the primary filtrant in our system. Next, we had a fine coffee filter, which kept our mix of cotton balls and charcoal from moving through the funnel and into the paper cup and water catcher. As Alex mentioned in the previous segment, some of the charcoal had moved through the fine coffee filter and into the paper cup. This is likely because the fine coffee filter has broken down after numerous trials.
Initially, we had designed a half-liter reservoir to flow into the filter. However, we weren't able to perfect the design by the time we needed to test, and so we had to scrap it and maintain the traditional filter. Overall, our group achieved our goal of minimizing costs in the rest of the unit in order to maximize the amount of charcoal we could purchase. This was demonstrated by our group having the highest percentage of dye removed after our test, and given more time, we would have successfully attached the reservoir so that it could seamlessly flow from the reservoir to the filter without any water leaking. However, given the time constraints, we were not able to do this. Additionally, we could have built a better base so that we could view the collecting of the dye without having to lift it up.
Here we have a titration curve made using our self-built Arduino multicolored spectrometer. We had to build the spectrometer in order to test our filtering apparatus. Using this curve, we were able to assess how well our apparatus was filtering the colored water. In our best test, we observed that our apparatus filtered out 86% of the dye from the water.
Here's a contraption we built to accurately measure with the Arduino. As you can see, this is the light side and this is the sensor side, and we would put the filled cuvette in the middle, and inside you can put the light in there and the sensor in there, and that ensures that it gets constant readings. And from Group 12, this is Alex, the science guy, signing off.